Well, good morning. As Bruce said, many of you have been to these workshops before, and we're actually going to, we run these in a way that we go through a lot of material, so hopefully I won't go through this too fast, but the idea behind what I'm going to talk about this morning is a little bit of the basic science behind rice, just to give you all an idea of why you would do certain management practices at certain times. What's important about when you would apply nitrogen or when you would raise the water, and why is it that you need to do that? So to start with here, we're going to talk about rice yields because that's what we're all about. And so I'm going to ask you, we're going to start right out with this clicker system, and I've not used it before, but get your clickers out. And, Bruce said this wasn't a quiz, but this is a quiz, actually, and you're all wired. All right, so what's the world record for rice? See how we're doing? Now we're getting some clicks up there. Okay, I think we're ready to move. The first thing I have to tell you is this is a trick question. There is really not a right answer because we don't actually know. So, by golly, I think most of you got this figured out, at least for California. And so the world record is actually comes from the hybrid rices in China. And these things are hard to verify. So if you look at the spread here, you can see that, there were 2 years ago, there were yields reported in India that were on the order of 220, but they're highly suspect. The Chinese hybrid rices, I think that is actually a verifiable yield, but it took place in one of the best places to grow rice in the world. And even the conventional varieties there will do 150. If you look at us, we are, even our statewide average is over that low number I gave you, and there's probably a lot of you in here who are in the 100-100 club. And for those of you who don't know what the 100-100 is, that's 100 weight on 100 acres. So even our statewide yields are above that low number I gave you. I've heard of 120, 100 weight on a field run basis here. And in our experimental plots, we've been up to 133 hundredweight. So if any of you have any numbers that are above that 120 for California, I'd like to hear about it. So what we're going to talk about is what is it that goes into making a high yield in rice. And these are the 4 important components, which we call yield components. I'm going to also talk about the growth stages of rice after we go through the yield components, because it's the growth stages of rice where each of these yield components come into play and where you have to make the right management practices in order to maximize those yield components. I'm going to say a little bit about harvest index at the end. I'm not sure if we still have a credit program for a strong corporation, but we'll talk about it at the end when I get to that point. So let's start with yield components. A couple of quick definitions. You'll see the word spikelet in here, and that's synonymous with grain, okay, with an individual kernel. And panicle, of course, is the loose head of rice. As you know, wheat has a very tight head, and in rice it's different. We call it a panicle. So the first yield component which is panicles per area, is really, what contributes to that is the established seedlings, which, as you know, is always a struggle out there. Some years it's okay, but generally that we're really on top of that because we know we need to establish a good stand, and then the tillers per seedling. So let's examine that a little bit more closely in a minute, I guess. The second yield component is spikelets per panicle. So that's the number of seeds that are produced on an individual tiller on that panicle. The next one is the percent filled spikelets. So in other words, we're really talking there about how many, we're talking about blanking basically. And then the grain weight. And all of those added together make up yield. So I'm going to show you here some real numbers. I mean, these would be typical numbers in California rice. So if you had a rice plant that had 60 panicles per square foot, and each of those panicles had 70 kernels, and the kernel weight was 30 grams per thousand. Now we don't typically, when we're doing these measurements, weigh an individual seed. We have seed counters that count out 1,000 seeds, and in any event, that's how we come to seed weight. And let's assume there's 10% blanking. What would the yield be? And I've put the conversion factors here, and I'll tell you all of this is in your manual, so you can digest it later on. But basically, and there are a number of ways to do this iteration, but if you multiply these out with 60 panicles, 70 kernels per panicle, 30 grams per thousand, and 10% blanking, that's the yield you would get. Now that's, if you were to go out and make all these measurements in a rice field that was producing 10,000 pounds, you'd be right somewhere in that ballpark on each one of those yield components. So now let's take an example where we have 30% blanking. So you go through the calculation and you can see already you're 2,500 pounds below just by 30% blanking. And a few years back, and I don't remember the exact year, we had a lot of folks that had serious blanking problems that were way beyond 30%. Even in fields that were just planted across the street from each other 2 weeks apart. And we're going to talk about why that might be later on. And I think also when we talk about water management, that will come up. So let's take a look at seeding rates and seed density. You guys, am I blocking you over here? You okay? All right. So this is data that we've collected from field experiments. And so there's typical seeding rates here from 125 pounds per acre up to 200. This would be a typical seed density. In other words, if you planted 125 pounds, you would expect to have 45 to 50 seeds per square foot. Of course, you all know seeds per square foot is, yeah, that's fine and dandy, but you're really looking at how many of those make it. Now, there is a range here based on varieties because seed weight is different for different varieties. So for example, this is the wide range here, S102, which is large seeded, at 125 pounds per acre would give you only 38 seeds per square foot. But with Koshiakari, which is a small seeded type, you'd have 55. Now, you might want to make adjustments for seed size. When it comes to varieties like that. Okay, panicle density is the other component that gets into the other part of the yield component, and this is the number of tillers per square foot. So if you look at, again, some data that we collected where we had, whoops, I'm going to go back here, where we had seeding rates ranging from 30 to 210 pounds per acre, You can see the plant stands here. This is the actual plant stand. And then you can look at the panicle density here, which is, in this case, lower, like you would expect, at 30 pounds per acre, higher here at the high seeding rate. But basically, once you get above 60 pounds per acre seeding rate, they were fairly constant here. And the number of tillers per plant then ranged in the order of 2 to 3 in this area in here, which would be a normal seeding rate. Of course, I know there are a lot of folks here that like to plant 200 pounds per acre, you know, that's an insurance policy, but high seeding rates can run into issues too. The spikelets per panicle in that situation, you can see that there is a little bit of compensation with the spikelets per panicle in that at the low seeding rate, when there are fewer panicles per square foot, you can have higher number of spikelets per panicle. You remember the calculations that I was doing earlier were in that range of 60, and you can get up to 90. In some of the hybrid rices, for example, they go way up. But this number is one of the things about rice, that it is really a crop that compensates for low tiller density. But it will not compensate, as I'll show you pretty soon, in terms of increasing enough to make the kind of yield that you'd like to make. The number of field spikelets, that's blanking again. Normally blanking in California is on the order of 12%, and you can see that the blanking is pretty constant across the whole thing. And grain weight is the one thing that doesn't vary. Even though you might have a low density, the grain weight is pretty fixed genetically. So you really can't influence it on the positive side, but Mother Nature can screw you up with a north wind, or if you drain too early, that is a place that your seed weight can go down. So if you look at yields across here, you can see in this case that yields, once you got up above 60 pounds per acre, were pretty constant. Now, I'm not recommending 60 pounds per acre. Of course, the breeders use it, and drill seeding is somewhere in this range usually. The breeders use it because they're looking to produce as much seed with as little seed as they have to plant, so they'll often plant even lower than 60. But again, once you get down in that range, as you all know, you don't really have much insurance in the way of a stand. So, can't see the color very well here, but there is the issue of when do I replant if I have a low stand? You know, it's always a dilemma if you have, you know, a situation where for one reason or another, the stand is poor. And you go out and count and you say, well, you know, I've only got 7 seeds per square foot. Do I get into the business of replanting, which is, of course, always problematic, or do I stick with what I have? Or do I come and seed over the top of it, which is more typical? And if you do that, then you have typically a range at maturity which can affect quality. So what I've done here is just to go through these calculations. Let's say that you had 7 plants per square foot, which is pretty much in the area that we recommend is, you know, it's the bottom end of being okay. So that would give you probably 5 tillers per plant or 35 panicles per square foot. So what I've done here is in parentheses is the 60 panicles per square foot that I made those calculations on when we were doing that, when I was doing that demonstration of yield components early on. So now you've only got 35. You'd like to have 60. So if you now look at what you've got in the panicles per square foot, or rather in the kernels per panicle. Remember, we compensated now, we're up here at around 90 because we have a low stand, as opposed to 70. If we had a 10% blanking again, and we went through these calculations, what you find is that 7 plants per square foot, you'd be at about 81 sacks, as opposed to what we calculated in that first the first example of around 11,000 pounds. So you can get an idea here of where you're going to come out with that low plant stand of 7, and it gives you an idea of what you're giving up. But on the other hand, what would happen if you had to replant or add seed to what you've already got there and try to establish a stand on top of what you already have. Okay, so what I want to talk about next are the growth stages, because it's really the growth stages that impact each of these yield components. So some of the yield components are affected early, some later, and right on through the season. And that means that if you're going to do a management practice to impact say the tillers per square foot, you need to be there when that growth stage is occurring. So we really have 3 growth stages that we talk about in rice: the vegetative stage, the reproductive stage, and ripening. So this in general is the vegetative to reproductive stage, and I've put these numbers here for early and late varieties. So this would be like M401, and these would be the more typical M202, M206, and so on. So tiller initiation starts at about 25 to 30 days. Panicle initiation we'll talk about in a minute, and then out here is flowering and ripening. So the seedling stage is that period up to about 4 leaf. And why is this stage critical? In these early stages, up to about the 2nd leaf or 3rd leaf stage, you're dependent almost entirely on the carbohydrate reserves in the seed. You're not, the rice plant at that time doesn't have enough leaf area to go on its own. So if you have something that comes in and, like for example, shrimp, and starts chewing on those seeds, you're going to have issues with how much carbohydrate you have left to get that plant up and out of the water. That's the stage we call heterotrophic, that period, because the plant is dependent on what it has in the seed. Once it gets out here to the 4-leaf stage, it begins to produce its energy from the sun, and we call that autotrophic. Now, in these early stages, the question is, I personally I don't like shallow water. I would rather see rice coming through at least 4 or 5 inches of water, and I know people who even are up there around 6 or 8 inches of water. And from a weed control standpoint, that's really important. But on the other hand, it means that you're right at the edge of the ability for the plant to get through. And deep water also affects tillering, but on the other hand, it does really help you with weed control. So the next stage is the tillering stage. And I think more than anything else, good nitrogen management, good fertility management is critical for good tillering. And so obviously you want to have the adequate nutrients there at the point of tillering, which begins at about 25 days. And if you look at tillering, you know, we've had when we first started using thiobencarb, we were looking at that two-leaf stage. You didn't want to be, you wanted to have what I think it was 70% of the leaves of the plants in the two-leaf stage before you could use it. And there was always this question about what's the first leaf and what's the second leaf. And you know, and there were in different parts of the world, they counted these leaves differently. But we call the spike leaf the first leaf here. So this is the spike leaf, which is the first leaf. And then the second leaf is the first leaf to unfurl and go flat. But the important part about this with regard to tiller initiation is that tillering starts at when the fifth leaf is just coming out here. So the tillering is starting at the second leaf when the primary plant is in the fifth leaf stage. When it goes to the sixth leaf, we get another tiller here. Seventh leaf, another tiller here. And all the tillers that come off of this initial plant are primary tillers. We also can get tertiary tillers that come off of the first and second tillers, but it's the primary tillers that come first and are more synchronous, and it's really those primary tillers that you're depending on, because remember, you're really only talking about 3 tillers per plant here on average that make a panicle with the seeding rates that you use. If you look back at that data I showed you earlier, those are really what we're looking at when I say tillers, are primary tillers. So let's take a look at seeding rate versus tiller density. So if you look over here, this is total, not individual plant tillers. This is the total tillers in an area, all right? So if you look over here, this would be like, if you were right at this level, it would be 60 tillers per square foot. So if you plant at 56 pounds per acre, you can see that, you know, the tillers are coming up like this, and there's always a little bit of tiller loss even at this low seeding rate. So right here we're up above 80 tillers per square foot, but ultimately we're down here in this 60 tillers per square foot, which is what I did all those calculations on for that 10,000 pound yield earlier. Now, if you look at tiller density in a more typical situation, which is where you're planting 134 pounds to 150 pounds per acre, you can see the tillers go clear up here to 120. And so what you've got here are primary and tertiary tillers, and they begin to die off over time, and you really wind up again with about the same amount of fertile tillers in the end. At high levels of seeding, you can go clear up here above 140, 150 tillers and we're talking just in a square foot. So why are high seeding rates sometimes problematic? Well, okay, you feel good about having that nice stand out there, but if everything goes right and you have a super stand, which is what we're talking about here, you have a lot of biomass out there, and that's where disease can be transmitted, where culms, stems can be weak. So, you know, I'm not telling you don't plant 200 pounds per acre, but what I am saying is that that's one of the issues that you have to deal with sometimes if you really get a super stand out there. Of course, the other end of the spectrum is worse, right? Okay. So now we get to the reproductive stage, and that begins about the time that tillering ends. And we're looking there at panicle initiation. And panicle initiation, I mean, you've all probably been out there and cut the stem to look for panicle initiation. And there's a lot of variability. And so this is data that we collected from 2000 to 2008. So there's 8 years of data here from our variety trials all around the state. And then we've got, you know, the 4 of the major varieties. But what you can see here is that these are the dates that this is what we can actually measure is 50% heading. Right, Ray? Ray Winnig back there, I don't know how many miles he puts on a pickup every year going around to these trials, but it's a lot, measuring 50% heading in all of our tests. So what we did here is try to extrapolate back to what tiller initiation would have been in each of these, or panicle initiation. And what you can see here is that the range in panicle initiation in Butte County, for example, was very wide over those 8 years. For all of these varieties, you know, you're talking about a variation in the time to 50% heading across the board here of a range of probably 10 or 12 days. So what does that mean? That means you got to be out there looking for, you got to be out there with, on top of this, looking for when panicle initiation actually occurs. I don't think there's any substitute for trying to figure that out without being out there. Now the panicle is visible in the stem at about 7 days after PI. So when you go out there and start looking for panicle initiation, you're not going to be able to really see when panicle initiation is actually occurring. You're going to be after it, after that time. At that time, the spikelets per panicle are already formed. So if you're going to be raising the water, for example, which we'll talk about in a minute, you want to be doing it before panicle initiation. There's the young panicle at a very early stage, but probably those spikelets are already formed. There it is again later on, and clearly all the spikelets would be formed by that time. So if you're going to get cold temperature induced sterility, you'd already have it at this point if you hadn't raised the water. And this is just an example of blanking. So I think we'll be talking more about the importance of raising the water as a heat sink, and I think those of you who are actually farming rice are very familiar with doing this. But it was interesting a few years ago when we had those cold temperatures that rice fields, as I said earlier, right across the street, right across the road from each other, but planted a couple of weeks apart. One was yielding 9,000 pounds per acre, and the other one was, you know, 4,000, 5,000 pounds per acre. So it's a huge difference, and it's one that you really need to be on top of. So what's a good indicator? We say that the collar alignment of the flag leaf is probably a good indicator of when panicle initiation is occurring, or when, at least of when the cold sensitive period for pollen formation is. What happens is cold temperatures of 55 degrees or less will kill the pollen, so you don't get fertilization of the grain. That's the issue. And if you and remember that at that point the panicle is still down. The rice hasn't really started to elongate. It's just beginning to. So when you cover it up with water and raise that water up, you create a heat sink there that keeps the panicle warm and prevents this. So if you look, though, at these collars, you can see that the flag leaf here is, if right here, I'm going to actually click the next slide, but right here, the collar is below. Right here, the collar is aligned, and that's the sensitive period. And right here, it's too late. So, it is at this stage, as I said earlier, that the number of spikelets on that panicle are formed. So that is the third part of your yield components. So the fourth yield component is seed weight. And seed weight is very tightly controlled genetically. So there's no upside that you can do, but there is a downside. And draining, for example, too early, that's a tough decision sometimes, but draining too early or a north wind coming in can, as we say, pinch the seed, but basically you're lowering the seed weight and lowering that yield component. Okay, lastly, a little bit about harvest index. The reason I want to talk about this is that I know for a while there was, I think, a CRP program that gave credit for strong corporation, which is basically carbon sequestration. I don't know if that program still exists. Does anybody know whether it does or not? I wouldn't be surprised if it were to come back in, given our concerns about carbon and global warming. So I'd like to go through this because we are still growing tall Japanese type varieties, and so this does come into play. So the term harvest index is really very simple. It is the amount of grain divided by the total grain plus straw weight. And the taller varieties, which were the traditional varieties that California grew before all of you guys started growing Calrose short semi-dwarfs, the old Calroses, which stood up to about here, had a harvest index that was pretty low. You produced a lot more straw than grain. And the real plus that came from semi-dwarf varieties is that the harvest index was a lot higher. That meant actually that by having a lower, I'm going to call it a fulcrum, by a lower height, you could put more nitrogen in it and produce and push the yield up. And that was really the basis for the Green Revolution in rice globally. So just as an example here, if you look at a tall variety that produces 6,000 pounds of grain, 7,000 pounds of straw, the harvest index is lower, 0.46 in this case. If you look at a semi-dwarf variety, it's higher. Actually, more than half of the total plant material is grain. So let's take a look at a typical situation with tall and short varieties, because you wouldn't fertilize a tall variety like you would a short variety. So here, this was a study that we did where we looked at nitrogen rate and grain yield in a tall and short variety. So here is the short variety, the semi-dwarf variety, and you can see that yield was highest at 150 pounds per acre, and then it started down. But in the case of the short variety, the tall variety, yield was peaked at about 120 pounds per acre. So you fertilize differently for these two. And if you look at the straw yield, you can see that the straw yield of the tall variety is definitely higher. Even at 120 pounds per acre, it's higher than the short variety is at 150 pounds per acre. And if you look at the total yield, it's about the same. It's just that you got a lot more straw with those tall varieties. Well, again, this is the real data here from that last example. I won't go into it. It's basically the same calculation that I made earlier, but what's important here is that you want to use, if we get into a program where there is credit for strong corporation, and when there was a few years ago, the folks that were growing tall varieties were getting, I would say, they were getting shortchanged on the program because they were calculating the straw as though it were being produced by a semi-dwarf variety. So if we get back into something like that, we have the data that can, whoops, I guess there we go. So we're back to the clicker. Now this is the real test. This isn't a trick question anymore. So get your clickers out and answer that question for me, if you would. What yield component can be best or most influenced by good management? All right, are we ready for the answer? By golly, you guys are A-okay. All right, let's go to the next one. What yield component is least influenced by management practices? Okay, are we ready? And I don't know, Bruce, how do we grade a class like this? We can't give everybody an A, right?
We're grading you.
Yeah. Well, anyway, so my question is, will you break the yield record? So it depends on which one you want to go at, right? Thank you.